So thank you for coming. I'm Cynthia, a postdoc at Carnegie Mellon University's Human-Computer Interaction Institute, and this is Accessibility Seminar, where we invite researchers and community members to teach us about disability and access. And today we have a fantastic panel. I am super excited. We're talking about non-visual methods for soldering, as well as how to, as academic researchers, we can do better to engage with the communities of people that we're interested in supporting and learning from. So to begin, I'll introduce each of our panelists, and I'll say their name, and then they can say hello, so they become prominent in the camera view, and then I'll read a brief bio about them, and then we'll jump into the panel questions. At the end, we'll host a Q&A. Oh, and just for like access notes, please stay muted if you are not communicating with us, and I'll kind of direct the Q&A when it becomes that time. This meeting is being recorded, and we will be posting a video publicly if that impacts maybe what you choose to say or not. Just want to make sure everyone's aware. So to begin, we have our first panelist is Chancey Fleet. So you want to say hello?
Hi, everyone. Thanks for having me.
Yeah, thanks so much for coming. We're super excited to learn from you. Chancey is an assistive technology coordinator for the New York Public Library and an affiliate in residence at Data and Society. She facilitates a ton of programs to help blind people and ally community members to non-visually create, design, and produce accessible tactile and 3D media. So glad to have you here today. And Josh Mealy is our second panelist.
Hi, folks. I'm Josh. Nice to be here. Thanks for inviting me, Cindy.
Yeah, thanks for coming. So Josh is a longtime kind of blind maker hobbyist, and he's also an accessibility researcher professionally, and he's a physicist by training. Josh has decades of experience translating instructions into non-visual formats, like instructions for how to make and build items. And he also manages a pretty cool documentation called the Blind Arduino blog. So you might want to take a look at that for lots of cool tricks on how to do Arduino non-visually.
It's a little stale at the moment, but yeah, please check it out.
It's super useful. That's a lie. It's super useful.
There's some evergreen content there. There really is.
Particularly for getting started with physical computing when you're working with blind people. It's really useful. And finally, we have Lauren Race.
Hi, everybody. It's great to be here.
Yeah, thanks for coming. So Lauren is an inclusive designer and researcher, and she's currently a fellow at the Ability Project, which is housed at New York University's Interactive Telecommunications Program and Occupational Therapy Department. Lauren has done some really, really cool stuff. Being an academic researcher, I commend the work that she's done to publish documentation to the public. So she has web pages on things like accessibility tools for physical computing, as well as detailed documentation of the soldering workshop we'll be talking about today. So now that we've finished introductions, we'll begin the panel. And this first question is for Josh. And so I'm curious, Josh, if you can kind of fill us in on some key background information about making as a blind person and some of the work that you and others have done that makes something like the workshop we're going to talk about today possible.
Sure, and thanks. And I'll try to be brief. There's a long history to blind making, but I'll compress it and try to, save your questions, save time for questions later. So blind people, I like to call blind and disabled makers in general, I like to call us meta makers, because in general, before we can do the actual things that we want to do, we need to figure out how the heck we're gonna do them, because so many processes and tools are inaccessible. I started at a very young age, playing with things, breaking things, experimenting with building and deconstructing things, and so I got a lot of experience early on, but I didn't realize when I was young how deep the history goes. Blind people were, for example, extremely active early on in the ham radio hobby, and ham radio was really great for blind people because there were no pictures. You couldn't send a schematic. You had to communicate verbally or even via Morse code what the schematic was and how to build different types of equipment. So blind people, blind makers early on got a lot of, borrowed a lot of stuff from that early verbal ham culture. When I was first sort of becoming, when I went to college and was majoring in physics, one of the classes I had to take was a basic semiconductor circuits lab. And while I had built and broken lots of things as a kid, I had not learned to solder. I had not learned how to really build stuff from scratch. So I learned a bunch of stuff in that class, but in order to prepare, I found a number of blind mentors who had done this stuff already, who had learned to solder, who had accessible tools, and it was really great to finally connect with blind people who not only had the background that I needed to build on, but who could tell me how to build the kind of accessible equipment I would need if I was going to continue. These blind mentors had already created things like a DIY magazine, the Smith Kettlewell technical file that was a Braille magazine by and for blind electronics enthusiasts, which described how to build all sorts of accessible equipment, stuff that you couldn't possibly buy off the shelf. Again, fast forward to when I was a postdoc and got my first postdoc at Smith Kettlewell, where these mentors were based and where a lot of really cool work was being done. I stayed at Smith Kettlewell for 20 years, progressing through from postdoc to scientist to principal investigator to associate director of the RERC on low vision and blindness. And through that progress, I went through lots of stuff, but ultimately came back to a really fundamental thing about accessibility and making an empowerment, which is the fact that blind people can't buy the stuff they need, so they need to be able to make the stuff they need. And when Arduino and physical computing became really, exploded in the last decade or so, I realized that it was easier than ever now for blind people to make their own stuff, but there wasn't enough documentation on how to do it. So that's how the Blind Arduino project got started. Chancey and I were together very early interested in building the kind of documentation and community that would support blind makers in a world where microprocessors were ubiquitous and cheap. And so soldering is just one of the many skills that people need, but it's really cool because it communicates a number of things to the participants and to the rest of the world, basically saying, hey, blind people are here, we can make, and by the way, we can also use tools that the generic you might have thought weren't actually accessible to us, like soldering irons that are hot, or wires that are colored, or other things. So I'll stop there and let you take things back there, Cindy. Sorry if I went on too long.
No, that's great. Thank you for providing that background. I think we can sometimes forget in our in our roles as technologists to create new things that there are often these really rich and deep histories that have a lot of insight and wisdom. And so if y'all read the invitation to accessibility seminar, there's a link to the technical file. If you're watching the video, you can just search, the Smith Kettlewell technical file, and that's a really wonderful piece of history. And Josh, thanks for your work to digitize that. So our next question, we'll switch gears just for a bit and kind of hear a different perspective, that of, the academic researcher, the professional designer, and what does it mean to join with, blind community members. So Lauren, I'm curious to hear a little bit about how this journey began for you and how you learned to kind of be responsive to and working with a community. So
Yeah, sure. So basically, it all kind of fell into place just as things do. I was a second-year grad student at NYU ITP. ITP, for those unfamiliar, it stands for Interactive Telecommunications Program. And we describe it as like an engineering school for artists or an art school for engineers. So it's this like very collaborative, creative environment where you all kind of get together and tinker and build stuff in a lab. And so I had TA responsibilities, and part of those responsibilities were making sure that the learning material that we use at ITP was accessible. So one of the specific things I had to do was to convert visual circuit diagrams to tactile format. And as I started doing it, I have a graphic design and art direction background, but I don't have a tactile design background. I have a visual design background. So as I was doing these things just to help my instructor, the two of us realized that we didn't have the skills to do it effectively. So we went and we got advice from community members. And in this case, it was Josh and Chancey. And so they came to ITP, we hung out, we talked, we listened, and then we took that advice really seriously. And Josh had sent us the article that was provided called Blind Eye for the Sighted Guy, which really helped us understand our sighted biases. I have a ton of sighted biases. And Chancey also suggested that I volunteer at the Andrew High School Braille and Talking Book Library here in New York City. It's on 23rd Street. And so, so I did. And fast forward to a year later, I was a volunteer at the Andrew High School Library, and we were hanging out more socially. And that's how the workshop even came up for non-visual soldering. We were just hanging out and talking about it. And, we were talking about how there needs to be more non-visual maker workshops. And Josh offered to come out from San Francisco to teach it. And I was like, no way, this is so cool. And I saw it as an opportunity to collaborate between the Andrew High School Library, the Blind Arduino Project, ITP, and the NYU Ability Project, which is where I was a fellow at the time with Amy Hurst. And so I pitched the project to my advisor at ITP, Tom Igo, who suggested that I propose it to the dean. And part of my fellowship responsibilities was community building. So there were pockets of money for this type of thing. So I received allocated funds for projects such as these. And, ITP, like I said earlier, it's really collaborative. The culture is community driven. So students and faculty are really encouraged to do community engagement like this. So it was really well received as a project, and the funding was really supported by the department itself. And the best part about ITP being really collaborative and a really tight-knit community is that it was really easy to recruit volunteers within that community who wanted to learn non-visual workflows for building circuits. So that's where I come from with this project.
thanks so much, Lauren. I think people ask a lot of questions of like, how do I know if I'm doing things right? Something I admire about Lauren, like a real sign, is that she has genuine friends in the blind community. I don't hang out with Lauren because she's my colleague. Like, I intentionally seek out time to hang out with her. So I really appreciate you for telling that story. And I think we have a lot of lessons we can learn about, when people teach us things, like taking those lessons really seriously, reading the things that people send us, volunteering in the community where people direct us, and then you get to things like this. So kind of fast forwarding to the workshop actually being implemented, Chancey, I want you to tell us a little bit about this kind of like philosophy of access kind of as a comprehensive experience, and as well as how to set people up to actually be successful at these types of making and learning workshops.
So sure. So my background, I'm the assistive technology coordinator at NYPL's Andrew Haskell Braille and Talking Book Library. And we actually, a bunch of blind activists, including me, started our tech program back in 2010 as volunteers while I was working somewhere else. And I came on board in 2014. And we started out just doing tech coaching mostly for beginners. But over the years, as I grew my network of like blind community mentors, I started to realize that we could branch out and do things that were a little bit more ambitious. So we started the Dimensions Project, which is for giving people access to the means of production for 3D printing and tactile graphics. We partnered with Josh and John Schimmel at DIY Ability on starting Arduino project workshops. And we started kind of branching more into STEM activities and physical computing and things like that. And it's been a really fun journey for me because I'm not someone who ever perceived myself as having aptitudes in STEM, and none of it has come naturally to me. And I realized that's because I was raised in environments and labs where I wasn't set up to think that I could succeed. I would be told that I could go read a book or do something, more suited to me, or I might be helped through the steps of a process, but I'd received so much support that I emerged from the process without any confidence and without even maybe being able to explain the process because I'd been assisted so much. So the philosophy of access that we use at the library is that our source of strength is our community, and we learn best from each other because we understand our own workflows, we understand our access needs, and we understand how to negotiate access needs with other folks. And it's also easier to believe that you can achieve an objective if you're learning from someone who works in the same way that you work. So that's a big part of our philosophy of access. For this workshop, I was excited to partner with Josh and with NYU and do it outside the library. We don't quite have the right insurance or the right ventilation for soldering, so we had to find a place to take our physical computing work to the next level. And we as a team did a number of things to try to set up attendees for success at the workshop. Not just the soldering content itself, but the entire workshop, the entire weekend. Let's see my notes, sorry. So for example, we created an environment where there were no inaccessible materials. This means that our schematics, our circuit diagrams of how to build the circuit were not just available in print, but they were available as tactile and braille. And we also had textual descriptive instructions that were available online. Our content was created and instruction was led by Josh, who's a blind instructor. We did everything we could to recruit diverse blind people from different ages, different geographic backgrounds, different backgrounds in STEM. And we did give priority to folks that expressed that they would be able to commit to helping teach the next cohort. It's really important to us to be able to propagate what we know. One of the reasons that blind shop activities and lab activities aren't more prominent is that we have to learn directly from each other. So if we can grow the base of people that are able to teach the skills, then we can make sure that those skills can get out to the people that need them. We also built in elements of kind of the hospitality to be as accessible as possible. So we had non-visual friendly transit instructions to get people to the workshop site. We made sure that there were social activities after the workshop. On one evening, we went to an accessible exhibit at the Dibner Library that was all about the history of other methods of tactile literacy besides Braille. We made sure that all the venues that we went to were accessible, and just little things. Not only were our supplies organized in the lab, but we even had gaffer tape and Braille labels delineating snacks and drinks to the side so that people could find their own refreshments and do that independently. One of the most important things that we did, though, was be really intentional about our volunteer training. So we had a bunch of volunteer assistant, TAs from the NYU community, and they were cited, and they needed to understand how to interact with our participants, with our students, on terms of equality and in a way that set folks up for success. So that meant knowing that people have their body autonomy, that the way to guide somebody isn't to reach out and grab, that the way to guide someone is to use descriptive verbal instructions. There is a proper way to offer your arm, and some people prefer to go by a human guide, and some people prefer not to, and that's fine. We made sure that they knew that blind is not a bad word, that it's an identity that we have pride in, that it's something that can be talked about. And we made sure that our volunteers knew not to intercede, not to do physical interventions, not to do a piece of the task for a student, because what can feel like helping in the short term can take somebody's sense of agency and confidence and independent completion away. Even a little bit of that can be harmful. So we made sure that our volunteers had a context for how to interact with students. And we had that conversation again with students in the room, so that students themselves could share their preferences and talk openly about it, because there are going to be frictions when the two communities come together. Everybody has internalized biases, you know, people with and without disabilities have them. And so we talked as one group about how to address that kind of thing respectfully and calmly and in a happy way. And I think we were successful at that. I don't think that there was too much friction. We made sure that our students got a descriptive tour of the workshop space and the surrounding area so that they knew how to move throughout the lab and move to other facilities, other rooms that they might need. And we made sure that everybody knew where supplies would be. And we made sure that everybody understood the layout of their soldering stations, where their soldering iron was, where they could clean things off and rest things, some ground rules for keeping the tables really clear of anything that wasn't necessary to the project. Supplies were issued kind of one at a time as needed. And every time supplies were issued, everybody was able to pass them around and describe them and talk about how they worked and point out their key features. And then everybody had a little organizational divider pad at their stations where they can organize their supplies. And I think that's about it. Josh is going to talk about the actual techniques that were introduced for teaching non-visual soldering.
Yeah, thanks so much, Chancey. So I was actually a student at this workshop, and I think just something I always look for, and you know, as a disabled person, when I'm approaching spaces that might not be disability centered or may not be, are kind of those like content plus things. Like, is it just that you thought about the actual content is accessible, or did you recognize that like we're going to have social experiences, we're going to have to get to the workshop? So that was really meaningful to me specifically. I also just loved that there were snacks, so thanks. So so Lauren, actually, if you wanted to start your screen share, that might be a good time. We're going to be talking through some key images, and actually Josh is going to be leading this next part where we'll get into some of the specifics about like how do you solder non-visually.
Yeah, thanks. And again, I'll try to be brief. There's no way that we can really sort of talk about everything.
Hey, Josh,
but
I'm sorry, can I stop you for just a second? Lauren, can you confirm the screen share and everything is ready?
Yes, sorry, yes, it is shared.
Okay, sorry I interrupted, thank you.
No problem, no problem. Of course, you know, soldering is like, there are just tons of little nitty-gritty things that you need to know, which is why we spent a 3-day workshop on a very, you know, a relatively simple project. So I'll talk about a number of the techniques that we use, and if there are specifics that you want to know about that I don't touch on completely here, then we have the Q&A. The project was, so I mentioned earlier about how people build, you know, blind people have to build their own things. And a very classic first project for a blind maker to build is a continuity tester, an electrical continuity tester. There are a number of different designs that have been developed over the years, but the one that we like the best is a very simple high impedance oscillator that simply has 2 test leads, and when the continuity between those 2 test leads, when the resistance between them goes down, the frequency of the oscillator goes up. So when there's infinite resistance, when the test leads are not touching each other, you hear nothing, and in fact no current is flowing, so there's no need for an on or an off switch, so that's a really cool feature of it. But as soon as there's some current allowed to flow, the oscillator starts to click, and for very high impedance, very high resistances, you'll get just, you know, click, click, click. But as it goes down, you can get a very high frequency squeal up to, you know, up to about you know, maybe of 4 kilohertz, I think. And you can adjust the, you know, these parameters for your own continuity tester based, you know, depending on what regions you want things to be sensitive. You can design the circuit by adjusting the capacity, you know, by adjusting the RC circuit that's in the continuity tester. But the continuity tester is a super useful tool for all sorts of things. You can measure resistors with it, of course, but you can also test, you can test diodes to see what their polarity is. You can test transistors to make sure you know where which one is the base and what's the, you know, the emitter and the collector. You can test capacitors to see, you know, get a qualitative sense of how large or small they are. You can, and of course you can use them for, there's a bunch of other stuff, but they're a super useful, very basic tool, and they're relatively easy to build. So that's why we start with that. So let's talk about the soldering stations that we used. It's really good to use a constant, you know, a temperature controlled soldering iron so that you can set it at the temperature that you want rather than worrying about how hot it's going to get. So we use these soldering stations that include a place to put your soldering iron and a place to wipe your, you know, to clean your soldering iron. And that's really important. And one of the things that we do with these soldering irons is we start cold. We don't just, you know, throw people in at the deep end. We say, okay, here's your soldering iron. Let's use it to explore while it's cold. And essentially, a lot of the techniques that you use for non-visual soldering are very similar to a, wow, we're losing people. I must be doing a bad job. But basically you use tactile techniques with a soldering iron that are very much like the ones that you use with a white cane, except that your soldering iron is much shorter and much hotter. So you need to be, but the tactile feedback that you get from it is very similar, and some of the techniques that we use with the soldering iron are also pretty similar. So that's, you know, so one way that you test for safety is to know, you know, to feel confident about how you, you know, where you're going with the hot tip of your soldering iron before you take it out of the holder. You also want to make sure, of course, that like there are no trailing cords or things that your hot soldering iron is going to actually damage if it touches them. So you need to be aware of that. It's also really great to make sure that you're, you know, before you pull out your soldering iron, that everything's set up exactly the way you want it for your work. You don't want to have to move a bunch of things around while you've got the soldering iron in your hand. So getting ready is a really important safety thing. But really, one of the things that is important about the way we did this workshop, we didn't focus a hell of a lot on safety. Safety is important. But one of the things that you can do if you talk too much about safety, especially to some beginners, is to make people more nervous than they need to be. The soldering iron is hot, but it's not going to kill anybody. You could get a little burn, but it's no worse than the burns you might get while you're grilling a hamburger, which lots of people do without vision all the time. And it's, you know, you can look up, you know, if you do a little Googling, you'll see that there are plenty of like blind podcasts and stuff about blind barbecuing and blind cooking, and nobody seems to be too worried about it, but soldering irons appear to be more nerve-wracking for people for some reason. So focusing too heavily on safety can definitely be a downside. So let's talk about the sort of tools that we use. A vise is one of the most useful tools for a couple of reasons. One is because it stabilizes your workpiece. You really want to set your workpiece up so that it's not going to move while you're working on it. You've only got one hand to spare, since one of them is holding the iron. So stabilizing your workpiece is really important. It's also really important ergonomically, by the way, to stabilize your own arm. It's often really good to rest your elbow on something to reduce the degrees of freedom. Anything you can do to reduce the error or uncertainty of where your soldering iron tip is relative to the work is really useful. So a vise is great for that, especially one that can be adjusted in a ball clamp, so that you can adjust the angle of it to be exactly the way you want it for your to gain access to the work site on your circuit board or your workpiece. So we also, one of the other things that the vise is good for is something called landmarking. Landmarking is basically a technique that we borrowed from orientation mobility with a cane, getting around with a white cane, and creating what you do is you use objects in the environment for as tactile landmarks. And in O&M, what that is you use a mailbox or something to as a landmark to where where a building is that you want to be able to get to in the middle of a block, or you follow a curb in order to get to a crosswalk or something like that. So in soldering, we use landmarking as well. And one of the cool things that we can do is use the vise as a landmark. So you can use the soldering iron to find the edge of the vise and follow it along and get to where you want to be. And you can also create landmarks by using something like a stainless steel forceps, where you clamp the forceps onto the workpiece so that you can follow the edge of the forceps to the location where you want to be. Really super useful technique. Also, because the forceps are stainless steel, they're not going to take solder, and they're also not going to. They also can be used as a heat sink if you want to protect a piece from overheating. So they have multiple uses. So there are a few techniques that we use to know when you're at the right place in the when your soldering iron has reached the solder. A lot of the time, what we do is we don't feed solder. We just we put a little bit of solder on the work site beforehand, place it carefully. Maybe we wrap it around one of the wires that's going to be soldered. It's not the way sighted people do it, but it works really well. It might result in a little bit of extra solder being in that location. So you need to be really careful about using that technique when you are, soldering closely spaced socket pins or chip pins. But in general, it's a nice technique, especially for beginners. So when your soldering iron reaches the solder and the work site, there are a couple different ways that you know that it's that you're in the right place. First, you smell the solder. You can smell it melting. We like to use rosin core 6040 solder so it's already got its electrolyte. I'm blanking on the word, but it's already got everything. You don't need to add flux. That's it, flux to your solder. It's already there. You can smell the solder melting. You can also, if you leave a leash attached to the solder that's on the work site, the leash, the extension of the piece of solder that you're holding in your non-soldering iron hand will break as soon as the heat touches it, so you know that you're in the right place. Another thing is, if you touch one of the wires that is connected to the place that you're soldering, you can feel the heat. It conducts very well, and you won't burn yourself if you're careful, but heat conductivity is a great way to know that you're in the right place. And finally, because of the flux and the melting solder, it changes the texture. The way the soldering iron scrapes against the workpiece feels different. It's almost a squeaky sensation. So that's something that you develop as a sense over time and experience. And finally, in order to test whether or not you've made a good connection, we come back to our handy dandy soldering iron, handy dandy continuity tester, which is, again, the most useful tool you've got. And you can use it to test whether or not you've got a good connection. And you can often hear in the auditory display of the continuity tester, you can hear when there are cold joints, because there are it can be a little bit scratchy because of intermittent loose connections. If you wiggle it while you're testing the continuity of it, you can also hear loose connections very easily. So that's a way to know when you've done your job well. And you can also feel it. You can feel whether or not you've burned your solder or scorched your work. And you can, so there are tactile cues to that as well. I think I'll stop there.
Thanks so much, Josh. That was such a fantastic, like, the YouTube video on non-visual soldering. So thank you so much. So I want to move on to Chancey to just share a couple of, things that went super well and things that we can learn for next time about this workshop.
Lauren, you can probably stop sharing your screen.
So first, a couple of positive things. I think everybody, without exception, was engaged almost the whole time, and everybody successfully learned some basic soldering techniques. And I want to get back to what Josh was saying about safety and that fear factor. I will tell you folks that when I tried soldering for the first time in California at the Lighthouse Lab, it was roller coaster level, like anxiety and adrenaline. I think it's a really good thing I was stabilizing my hand, as I was told, because I'm pretty sure my hand was shaking, and it felt like the most effortful thing. And one thing that I noticed by the end of the workshop, because I did participate in the workshop as well and followed along all the project steps, is that I was just chatting and talking with people and really focusing on my work, but not thinking about anything being dangerous, because I had practiced with the cold iron and I had done so many joints successfully that, I just knew in my body where everything was. I knew that everything was fine. I knew that I had the situation under control. So I know that everybody in that room came away with a fundamental understanding of how to orient their workspace and organize the workspace, how to use the soldering iron, how to complete a joint. Not everybody finished their project, but everybody did get those fundamentals down, which means that any participant that goes to another space, an integrated space where folks might have concerns about safety or might have no idea how to support them, they know enough about soldering to know the basic techniques, know what's possible, and get themselves integrated into a space in the future. And I think that that's huge. One other good thing, since this was at NYU ITP, the TAs, the volunteers are NYU students, and we also had some volunteers who were NYU faculty. And all of those folks came into the soldering weekend with little to no understanding of non-visual techniques for soldering or any non-visual techniques for lab work. And I think everybody exited the workshop with heightened expectations for what blind people are able to do, which means that next time there's a blind or visually impaired student in that program, or as those people disperse and go to other projects, they're going to not only be allies in spirit, but allies in practice, and really believe that we have the ability to succeed in lab work and have some idea that even if they don't know exactly what techniques to use, they understand and respect that non-visual techniques exist and they're able to connect to the blind community. So I think that's a huge win. Some of the things that we could do differently next time, we had an assortment of soldering stations. Some of them were variable temperature, some of them were not. So in the future, I think we would choose to make our soldering stations uniform so that when the group is given instructions about setting their soldering iron, turning it on, getting it ready, the same instructions apply to everyone, and there are not any inaccessible controls. We did have some dials that needed visual interpretation, either from somebody that was there, or we can use an app to connect to a visual interpreter. That's another story. But it would be better if we had variable control soldering stations, soldering irons that had a tactile indicator. the more things like that, the more frictions that we can eliminate, the more time volunteers can spend directly with students. And having a lab that's friction-free in terms of accessibility also means that attendees can more readily help one another, which is a great way to increase the confidence of students as they're learning. We also, even though this was a relatively simple project from where Josh was situated, having had years and years of experience, for beginners, this was a fairly ambitious project, and it turned out to be a fairly intense pace. I think some folks hit a wall at a couple of points, and not everybody did finish their project, and also the hours were kind of long. I think if we did it again, we would make some room for people to pace themselves by putting more of the instructional material in a textual format or maybe an audio format, so that people could feel free to go ahead or stay behind. And we might have a range of projects and consider whether an even simpler project might be a starting point. I think that this would support the core mission, which is skill building and essential techniques, and kind of take the stress away from folks who may have felt a pressure to finish what was kind of an ambitious and complex project for a first ever experience. And that's what I've got.
Thanks so much. And Lauren, I'm curious if you can spend a few minutes speaking from your position as, in this academic space where we're really rewarded for publishing peer-reviewed papers. And I want you to talk about kind of why this workshop was done, what the purpose was, what the purpose was not, and how to kind of think about that, just resisting these kind of pressures we have to publish all the time.
Yeah, sure. So I think, one, it probably comes from my background. I don't have an academic background. I was an art director for 10 years in like ad tech. And so I just learned in the last year or so that, there's a currency with publishing and being cited. I learned all that from Amy Hurst. And also I would say that at ITP, publishing is not a requirement or expected, and it's actually kind of rare. It's really not a big part of the program at all, and nobody was really doing it until the Ability Project started to collaborate with ITP. Tom Igo, my advisor, had published some stuff on the side, but no academic publication comes from ITP. It's a terminal degree. We don't see a ton of folks moving into PhD programs. It's really more of a program of practice. So the only reason, again, why I got into academic research was through the Ability Project. And so, it's not expected to conduct research, and the workshops that we do, there's no intent to collect any data. The only reason I collected data for my thesis at ITP was through the Ability Project and getting an IRB. That's not a common thing. So what we do is we do workshops and we do stuff in real life, and only because of the Ability Project and my mentor, there's any reason to publish. I think my motivation for publishing is just getting that type of work that we're doing out there in the world and sharing it more widely, so people know that this type of stuff is happening, and also to make recommendations to other practitioners that they can do the same work. And I think that's Tom's motivation as well, is just to make sure that more people understand that there's non-visual soldering workshops that are going on. So yeah, I mean, it's tricky, right? Like I benefit every time I publish, and I'm very aware of that. So I like to keep a balance between academic research and practice, because this work really means a lot to me, and not everything that we're going to be doing is going to be publishable, I guess. The funny part is that we went into this workshop not wanting to collect data. That was one of the goals of it, and it wasn't until afterwards where it's not that we had collected data so much as we had observed a lot of things we would have done differently next time. And so we ended up writing it up as a poster for assets. So without the intent of publishing, we ended up kind of publishing. So again, I think it's something that if you should be having those conversations with your collaborators to see what their motivations are, if they're even interested in doing that type of thing, if it's something that would be symbiotic. But yeah, I'm not deep in that world, so I don't really have that motivation yet. But I do like writing. I like writing the papers. I think it's a nice way to kind of like culminate, or to like tie up some loose ends on a project. So yeah, there's not an easy answer to that question. I think it's just making sure you're communicating with your co-authors and your collaborators and seeing if that's even something you want to do. Also, there's the issue of privacy and your attendees, and we told our attendees up front that we were taking photographs of them, and they agreed to have their photographs being published. But not every workshop has to be about data collection, and sometimes it's just about education within the community.
Yeah, thanks so much, Lauren. And I'll kind of interject to think a little bit more with that in terms of, I think it can be easy for me, to say, oh, well, that's like a design department or that's a practice department. They don't do research, so I can't do what they do. But I think there's actually some really important lessons. So I'll kind of point out a couple of those that I learned just by witnessing this workshop. So as Lauren mentioned, like she started her journey by actually learning from the community. So asking for feedback, like how to make these tactile diagrams accessible for her students. And so actually this workshop was a way of giving back. And so I think that's something we can really learn from, and the ways that we extract from our communities for the benefits, for our benefits in terms of publishing. What are things that we can do where it's very clear that it's not actually the goal to collect even more data. But then there are creative ways. In this case, when they published the poster, they were able to use things like observation techniques or having like interviews among the facilitators and volunteers rather than like subjecting the blind participants to more kind of participation expectations. And so I think there are some really important lessons, even if it's very clear that maybe that department isn't as obsessed with publishing as ours. And then I think, what we can learn at a structural level is actually kind of built into the promotion and tenure process that ITP is community engagement. And so how can we advocate that is actually structurally supported and meaningfully rewarded. So very quickly, I'm curious if each of y'all can share just one takeaway or one thing you would like people to get out of this panel, either something that you want to re-emphasize or something that hasn't been shared. And we'll kind of go back in our customary order. Josh, if you want to start that.
Let me, sorry. So I think that the main takeaway is that that activities that teach, that activities that build skills can double as activities that build understanding, and that's really that's really one of the greatest things that was mentioned here. Just like the people that joined the workshop gained skills, and the people that helped facilitate and support the workshop gained a great deal of understanding of the blind community. Blind people that come into the Ability Project and ITP in the future are served by that as well.
Thanks so much, Chancey. What would you like to leave everyone with?
I guess I really appreciate the way that Lauren designed this whole endeavor to support the possibility of publishing, but also to create actual value in our community. I feel like the blind community and disabled and marginalized communities in general are kind of relentlessly data collected. Not a week goes by that I don't see like 2 or 3 surveys targeted at me. There are lots of paid studies where you can go and test out something. And, even though that stuff sometimes is paid, it's not adding anything to my life, and it's not making my community better. It might be making somebody's product better, and it might be helping somebody with their thesis, but it's not a direct investment in my community. And the work that Lauren and her team has done, and the work that I do with some other scholars in the community, isn't extractive at all. Research still gets done, publication still happens, interviews and data collection can even happen. I'm doing another project with Claire Kearney Volpe on teaching web development fundamentals to blind people, and we're getting some insights that are going to end in publication. But in that, we're designing the exercise in such a way that the community actually gets something of value that's probably just as valuable as the research product. And I think designing intentionally and designing a project only after really getting immersed and getting to know the community and finding out what community priorities and needs really are is so important.
Thanks so much. And to add a little bit of context, that work Chancey's doing with Claire, they're actually teaching blind people how to do web development, right? So somebody gets a course out of that research participation, and accessible web development courses are super rare. So that's the type of thing Chancey's talking about. Cool, Lauren.
Yeah, I was going to say something else completely, but then Chancey got me going on this, kind of these like studies that are conducted that are thrown around a lot. And that was something I observed happening in many spaces where like, a student would come in and say, hey, I made this thing. I'm done. It's done. You're welcome. Here you go. Like, what do you think? Do you like it? And the student wants validation. That's what they want, because they wouldn't, if they really did want feedback and really to iterate on a design, they would have come to somebody, one of their users sooner. But I do think it's really a good point of what Chancey says is that, oh my gosh, am I blanking on what I'm saying? This point about like collecting data and these, I know my point was collecting data and these workshops. And, we talked a little bit about about like volunteering and like immersing yourself in local communities. And I think when you do those kinds of things and you're starting to build relationships with folks in the disability community, you're breaking down that barrier of like, I'm the designer and I identify as non-disabled, and like, here are the folks in the community that now are my users and they identify as having a disability. And when you start to immerse yourself in that community and you're building relationships and you're building friendships, there's less of that that dynamic of, hey, I made you this thing, you're welcome, what do you think, can I have some feedback? And you're starting to build these community practices where everybody's a part of the same team. And so therefore, these conversations of data collection come up, and that's not really the goal anymore. It's about being a part of a community and doing something with the community that you really, fundamentally believe in. So I don't know if there's a huge lesson there, but I do think that people need to start hanging out with each other, basically, and stop having that giant divide, which probably isn't really good advice during a pandemic, but hang out with each other and you're not going to have this issue of like this division between communities.
Oh my gosh, thank you so much. This has been amazing. You said all the things. And this will be, a video that will last and live on. So we really have time for only a couple of questions. And so another postdoc in our lab, Amy Pavel, will call on folks if you want to use the raise hand feature. If you just have very brief question is what we have time for.
Great. It looks like we already have a question from Sunny.
Hello, everyone. I'm really honored to know about the workshop, and I was reading your article on Medium, Josh. It was wonderful. So my question is very simple. I come from India. When you have systemic inequities or systemic limitations in terms of finances or in terms of practical approaches to get more hands-on, what are the approaches to solve that problem? As in, I did my undergrad in electrical engineering. I used a lot of soldering iron and everything, but it was at home. At college, we were just shown an image of soldering iron and thought this is it. So when it comes to, blind and low vision users, they don't even get a chance to get more hands-on in my community. So what is?
Yeah. I'm not sure if I have a good suggestion for that. I mean, I think that the best thing for in situations like that is to make sure that there's sufficient support for as much description as possible for the resources that there are. So you may not be able to put your hands on, but if somebody can describe things, also, models or even just sort of objects that are similar to the objects that are being displayed might be helpful. So if a blind student wants to understand what a soldering iron is like, then they can use a pencil or or a screwdriver, something to sort of get the sense of what using a soldering iron would be like. But I don't think there's any real substitute for hands-on experience. But those are my ideas right away. Chancey, I'll bet, has some ideas.
I don't have anything.
Or maybe
to
we
add
should
right
go
now.
to another
Let's
question.
Go to one more question. I wasn't expecting to jump in, sorry.
There are not currently any other hands raised. So if you wanted to, if you want to comment
Can I throw
more,
something in then?
Yeah,
Because
absolutely.
there was one thing that while Chancey was talking, I realized that it was the story of like how her confidence changed was really great. And one of the things that I realized that we really emphasized in this workshop was that there's not just one way to do these things. Like when I went through the sort of techniques that I outlined earlier, that was sort of, those are the basics that I use, but there are lots of ways to do this. And one of the things that we really emphasized to our students in the workshop was that experimentation and problem solving are essential. And, if you find a way to do something that's different from the way sighted people do it, that's different from the way I'm teaching you to do it, that's probably okay. If it works, it's good. And so that was one of the things that we really hammered home, so that when those students go away and they come to a place where there are different types of soldering irons or different types of equipment or different projects that require different approaches, we didn't just give them a set of techniques. We gave them a way of thinking about the problem so that they can do their own problem solving and their own technique development, sort of going back to the fundamental principle of being a meta maker. So I just wanted to sort of circle back to that.
Thanks so much. And we are at time. So I am super grateful for all of the panelists, Chancey, Josh, and Lauren, for taking the time. We'll be posting this video within a few days, and I hope it's circulated widely because this has been an extremely valuable resource. But yeah, thanks so much, everyone.
Thank you.
That's it.